You can hear me. Okay. Thank you for letting me know. Of course, something always goes wrong immediately. Anyway, as I was saying, and you guys, as when you weren't listening, I am Cale Royer. I am not Blair Williams from Edelrid, but he is on the line and waiting for me to stop talking. Couple things on how this is going to work. At the end of the webinar, there are going to be some links posted in the comment section and the description of the videos, and that will take you to a little quiz that you take. If you get 16 out of 20 right on that quiz, then you are going to get submitted to the ISA for 2 free CEUs. Unless you are watching this in the future in a couple days, and in that case, that's going to be worth 1 CEU. But this video will live forever on Facebook and YouTube, and you can come back and take the quiz for 1 CEU at a later date. Now, a couple things that we've got going on. So right now we have a couple events coming up. Our next webinar is actually on the 13th. That is with Brian Kappa from Chip Drop. That's going to be a fun one. Chip Drop is a great service all around the U.S. where you can get a really cheap or a free place to dump your chips. People sign up for it at their homes, and then you go and you dump it. You don't need to make an appointment or anything like that. They kind of hook everything up. Come watch that. He's talking about green waste management. He's going to talk a lot about the business side of dealing with your expenses in getting rid of chips. Should be a good one. After that, the only thing I really have coming on right now is the Tucson, Arizona TreeStuff party in April. I am looking for more TreeStuff party hosts, so if you're interested in getting a bunch of people out together to do a rec climb powered by TreeStuff and trying out some new gear, go ahead and email media@treestuff.com or go to the application on treestuff.com/parties. The other thing that we have going on, which is kind of a hush-hush right now, is the free Produce promotion that is just the coupon code free Produce altogether, and you'll get a free Produce, an Arbor ID Produce, on any purchase of, I believe, $700 or more. It's a cool, limited edition, exclusive TreeStuff Produce helmet that's worth like over $400. And you can get it for absolutely free. So use that knowledge and go get yourself some helmets. Otherwise, I'm going to switch it over to Blair, and he's going to get us going on this webinar. Blair, thank you.
All right, Kel, thank you. TreeStuff family. Most of you probably know me. We attend quite a few of the same shows and get to interact with each other. So I'll be seeing the names coming up here, and I've already had Nick reach out to me. So I wanted to, Kel had mentioned that, Nick, you need to send Kel the Valentine's video. But with that, if you don't know me, the name's Blair Williams. I run Edelrid North America. So I am the distributor in North America for our parent company that is in Isny, Germany. If you don't know the brand, it's a real legacy brand. So Edelrid is 161 years old, founded in 1863. Edelrid is given credit for inventing the Kern mantle rope, inventing the sit harness, the quick draw. Very, very high-level engineering, product development. Today we have some of the highest quality products in the industry, and also some of the most innovative, as well as some of the lightest. So light gear on the Arbor side is great. On the rock climbing side, which we make a lot of products as well, we have the lightest wire gate carabiner in the world, the lightest solid gate carabiner in the world, the lightest certified climbing harness in the world, not Arbor's, but the rock climbing. And so for me, that is really just a testament of the brand's age, and then all of the decades of experience in material science and engineering and product development that we have. So if you haven't seen our products, make sure you check them out. And when you do look at them, look at the sewing patterns, the design, the weight, you'll begin to understand what I'm talking about when I talk about the high quality of the Edelrid products. With that, we had the privilege of sending Nick and Kel to Germany. I've been telling them for years how amazing the brand is and how impressive the factory and the production and the engineers and the whole team in Edelrid, Germany is. And they finally got to visit Isny, Germany, and spend quite a few days going through the facility, working with our rope management team, our product development team, our 3D printing team. And so in this webinar, they captured hours and hours of content that have been condensed into about 2 hours. And I just want to thank everybody in advance for participating and going through these different webinars. You're going to learn a ton about Edelrid. I think what you're going to get out of it is a much better understanding of who we are as a company, our ethos, what we believe in. And you guys all have a lot of options out there when you're purchasing products. And so I think knowing the brand and what they're doing with the profits and the influence you earn from them, or we earn from you, is kind of key. And so I really do hope after this webinar and these 2 hours that you guys are more in love with Edelrid than ever and more fired up about who we are as a company and where we're going in the future. So with that, Kel, I'll let you take back over, and appreciate you letting me introduce myself and the brand.
All right, great. So we're going to start with an interview between Nick and Martin Schlemmer. Was that his line? Did I get that right? Martin Schlemmer of Rope, the head of Rope Product Development. So, yeah, enjoy.
Hi, I'm Nick Bonner for TreeStuff.com, and I'm here at the Edelrid World Headquarters. Martin, thank you so much for having us.
Nice having you here.
Martin, quickly tell us your role here and what you do.
Yeah, here at Edelrid, I'm the head of the rope development department. So basically what the name says, I'm responsible for the development of the rope, and as the manufacturing of the rope is here at our facility, a lot of the time is like making sure as well that production is running smoothly, and in case something is not, because we're working with textiles, then people are quite quickly at my office, so this is part of my job as well.
Great. And how long have you worked here?
I've been here now for a little bit more than 11 years.
Wow, that's incredible. There's a legacy with TreeStuff and with Edelrid. TreeStuff was the first U.S. company to bring Edelrid safety gear in when Blair visited us just about 10 years ago. And I got to say, I'm very proud to be here today and to kind of bring this full circle. And we're going to share with our audience today the entire rope making process, a tour of your entire facility, and showing literally each step in really high detail. And it's going to be good. I think that people are really going to enjoy that look into the technical side of it.
Hopefully, yeah.
When you design ropes for arboriculture or for tower or wind turbine, what are some of the main considerations or some of Edelrid's ethos? What are you trying to accomplish?
So basically, as we are working with safety equipment, for sure, safety is the most relevant part for us. This is not non-discussable. And then for sure, we want to make ropes being as suitable for the scenario of usage as possible. So first of all, we are thinking about what's going to be key for the usage in this scenarios. For example, for arborism rope, it's going to be abrasion resistance, for example, is one key factor. So this is one thing we're thinking about with the material we're using, with the way we are processing the material, etc., etc. And so for every scenario, we are thinking about what would be the ideal rope for this, and this is what we're trying to achieve.
Interesting. And how would you say that looking at something like needing abrasion resistance versus elongation, how does that translate into your research or your development process?
So unfortunately, producing or developing, I would so say, standard rope is pretty easy for us. But in rope development, it's always, if you want to improve a certain factor, you always have to be aware that most likely the other factors and figures are going to drop down. So the most interesting thing is trying to improve one factor and try to get the others to stay the same, or at least not drop too much. And this is always a kind of a balance scenario we're working on. And this is what we do in most of the time. Yeah.
I feel like you kind of mentioned that making a simple rope is easy. And I think a lot of people look at rope and think, the materials are very, static's not the right word. The materials are known and the processes are known. What do you feel are some of the unsolved problems or kind of future problems for rope? Like, what are some of the things that you want to figure out but haven't?
So actually, it's the funny side is that some questions we believe are relevant for the future are very basic scenarios. So abrasion resistancy, for example, we're talking about. Everybody using a rope knows that this is a factor. Nonetheless, it's very, very tricky to get a testing set up, doing tests in a statistically valid manner. So this is something we're working on currently in order to improve that factor and to really prove that scientifically, not just like we believe this is the way, but really show this in figures. And for example, we believe that the treatment of ropes, which is currently mostly used for dry treatment, does have an effect on certain other factors. And we believe it or we do realize, for example, that the number of drops on the drop tests will most likely increase when you dry treat a rope. And as well, treatment might be interesting or is interesting for abrasion resistance. And then these are things we're working on one hand, in order to make our ropes as long lasting as possible. Then for sure, especially for the outdoor industries, environmental issues are a really huge topic we consider to be very interesting for the future. So working with materials not fully based on oil, basically. So maybe partially bio-based material and stuff like this. These are definitely driving factors for the future.
Interesting. And you mentioned the environmental concerns, and we also talked about abrasion resistance. And I think that on one side you have environmental concerns of production, but another thing that I know that Edelrid really cares about is making products last longer so that they don't need to be made again. It doesn't matter how much of the bad stuff you take out of production of anything is damaging to the environment. Yeah. And whether it's steel inserts in carabiners or increasing abrasion resistance, it feels to me like Edelrid is committed to having people buy less Edelrid stuff. Like, buy it once and it lasts.
I mean, we are very aware of the fact that our company is existing due to selling products. And as you mentioned, selling and manufacturing a product is always having an impact. And we are very aware of that. But if we're really talking about visions and where we want to go to, if we're talking about environmental friendlier products or friendly companies, this has to be the go-to way. So to really make your product as long lasting as possible. And yes, recycling and stuff like this is a part of the story, but it's always the end of the story. And so if we can produce ropes or carabiners or whatever being as long lasting as possible, this is going to be the best way to reduce the footprint. And this is going to be a long path up until that. But yeah, that's the vision we're working towards. Yeah.
Seems so easy, but in a world where things seem to be designed to fail and where they're updating our phones to make the batteries die, I think you kind of stand alone in that way, or at least in a small group of people. Should be very proud of that. Yeah,
we are. But as mentioned, I mean, we are very aware that currently we're still living on producing products, and this is paying my daily salary. But nonetheless, the idea for the future is to kind of change this, and this change is going to be slowly, but I think it's necessary. Yeah. Great.
Well, can you walk us through kind of at a high level how the rope starts as a filament and turns into a rope?
Sure. So first of all, as you mentioned, we're starting with raw material.
That's my gator now.
It was your gator. We do a lot of shoots over here now. No, so first of all, we're starting with the raw material, and the first part of the production, which is basically taken half of our facility, is processing the material in a way in order to get it ready to get onto the braiding machinery. So it's twisting of the material first, then for especially dynamic applications, we have to get more dynamic into the material than it has in the raw material. So this is basically done by a shrinkage, so shrinking the material. Then we have to get it in a processable way. So to get it on carriers for the braiding machineries, and the core and bobbins to run it through the braiding machinery as well. So this is basically the whole top floor of our facility. And when we've made that, then we go into the braiding machinery, so the braiding in itself. There we got a lot of options to make a rope the way we want to have it. So first of all, we do have two separate ways of setting up the machinery and the binding of the sheath material. So one option is the 1/1 braiding. So one yarn will run over the one yarn and then underneath the next yarn, or the 2/2 braiding. So one yarn will run over two and underneath two. This is the first step of making a rope or design a rope the way we want to have it. Then we have certain other factors. For example, if we're talking about stiffness in ropes, we are tending to make a difference between bending stability and pressure stability. So pressure stability is mostly driven by the amount of core we're pressing into a rope to either get it very stiff or very loose in the touch. And bending stability is mostly driven by the speed we're pulling the rope through the machinery. So whether it's a very open or a very, very close braid. And these are the factors. Then there might be a dry treatment depending on the rope and the usage scenario, packaging, check-in, and then shipping the rope.
A common thing that's mentioned in reviews or even a complaint about rope is that a rope will flatten out under a mechanical device. Mm-hmm. You could make a rope that didn't flatten at all if you want, or had extremely minimal flattening. But something that we found is that if the rope doesn't flatten enough, that the mechanical device won't actually be able to grab it. So it's really interesting to me how you are able to kind of keep all those different design considerations, in mind.
Absolutely, and I think that's one very important factor you're mentioning. When you're working with the rope is one part, and it's always going to be an interchange between the rope and the devices you're using for belaying or whatever. So this is very interesting here as well, as we have hardware development as well. We all have it in-house to do the testing. And yes, if you try to improve or change factors within a rope, you always have to check how it's going to behave in real scenario validation, and not only think about the rope, but always think about the behavior within scenarios you're using your rope.
From a development perspective, if you were looking at this rope and the decision came down to make it more abrasion resistant, mm-hmm. what are some of the design or engineering considerations that you would do to change the construction or the production method of this rope?
Yeah. So first of all, in this kind of rope, we do use a very thick material for the sheath. So compared to normal dynamic ropes, for example, we use ×4 twisting. In this case, we use ×13 twisting. So way thicker material in the sheath material for the sheath. Second part would be, you were talking about the flattening of the ropes. This is a factor as well. So in this scenario, we did use a braided core. So we're braiding the core first, and then we're braiding the rope around this. The second benefit is this would be very beneficial for the splicing of the rope. So if you do a spliced end termination, the braided core will make it way easier to do the splicing on that. And these are some factors we're taking into consideration when we come up with a rope. As well, for the material we're using in here, the sheath material is polyester in that case, due to we don't need the ability of shrinkage. We don't really want it for a static or a semi-static rope, so we can use polyester. Plus, the polyester does have I would currently say, a different behavior concerning abrasion.
Interesting. When I buy or purchase or even just kind of evaluate a rope, one of the things that I always look at is what most people would call a pinch mm-hmm. test like this. Mm-hmm. Talk to me about some of the considerations that would be made if you wanted to make the rope more flexible, so to make this eye smaller or to make it less flexible, where it would not constrict so small? What are some of the things that you might change about the production or development?
So as we were talking earlier, it's always a combination, or we consider it to be a combination of bending stability and pressure stability. So if I want to make a very flexible rope, I have the two options: either to take core out of the rope, so to make it less pressure stable, and this will make it softer in the touch or in the feeling, or to make the braiding more open, and then it will get more flexible as well. So these are the two factors I could use. Nonetheless, you have to be very aware that all the factors you can only use up to a certain point. For example, if I try to put out a lot of core length per meter of rope to get it very pressure soft, you might run into issues like sheet slippage and usage. So this is always something you have to keep in mind and be very aware of when you're designing ropes. So as mentioned earlier, if you're trying to improve one factor or push one factor to the limit, this will always have effect on the other factors. So you have to take that into consideration all the time.
When you started to design your tree climbing ropes, what were, before any of this existed, what were some of the first considerations, or what was the first step that you took?
First step is thinking about what a tree climbing rope, what is special about tree climbing ropes. And that's what we had earlier. I mean, it's just like, it has to be abrasion resistant because you're using it within the tree. And then the grip and the handling has to be very important because you're just like climbing up and down on the rope and using really the rope, and you're working with the rope in the tree. So first of all, we're starting with thinking about the scenario of usage and what are the challenges for the rope in this kind of scenario. And then we're trying to start to face these challenges and develop a rope as good as possible for this application.
And roughly how long does that development process take, right? You're going to make your first arboriculture rope. You've been making rope for 150 plus years. How long does it take from conception to production?
I mean, it's very tricky to say because it's depending on how standard, I would say, the development is. So if you're coming up with a tree climbing rope, and the idea, I mean, we know the scenario of usage, we know the material, and we do have ropes in our rope range. So coming up with a new rope would maybe last from the first idea to real going into production, I would say 2, maybe 3 years. If we're thinking about factors which are really more in an innovative way, so for example, we came up with more cut resistant ropes, we came up with mechanically recycled polyamide used within ropes. This might be developments taking a decade from the first test, so 10 years plus, depending how far it is off the normal standard you're producing, I would say.
I'm kind of shocked because you're not even phased by like the idea that 3 years or 2 years is a minimum. That's such a long period of time, and it really, I think, speaks to the level of commitment that Edelrid has. And then, maybe 10 years, and like that's a shocking amount of time to spend working on something. But I think that for the men and women that are putting their lives on these lines and using them around saws and braiding them against tree bark, that those things are really important. And I hope that the customers, I hope that you all appreciate the amount of work and effort that goes into producing these ropes. Is there anything about rope that you think people don't know or would want to know? Are there any like interesting facts? What's like your most interesting like gotcha about rope?
That's a real tricky question. Maybe I'm not the right person to answer it because, as mentioned, I mean, we are working here. I'm here for 11 years now, working 11 years in rope. So we are maybe now and then so focused on details that we kind of miss what actually people in there. So yeah, as mentioned, so we are looking so closely into details that we're some kind of stuck in there. But yeah, I think you might see a few facts during your tour through the production. I think the most interesting thing or the fascinating thing for people visiting us is that, like, braiding a rope is not only the braiding machinery. It takes this at least the same amount of effort. So braiding is one part of rope manufacturing, and the part which is before we even get to the braiding machinery is like a whole floor we need to get the material ready for braiding the rope. And as soon as people are here within our factory, they realize why a rope does cost some money if you buy it as customers, because they see that it's not that easy. Just take the material, setting it up to the machinery and run.
We were talking earlier as we walked through the facility about how much time is invested in making a hank of rope. And we talked about a set of rope being about 1,500 meters. That 1,500 meters, I think we figured out that it takes somewhere between 5 and 10 days to actually produce it nonstop going through the factory. So it's not as simple as, like you said, just taking the yarn, putting it on the machine, and bang, a rope is there. And as we walk through the factory, you're going to see all the different stages where the yarn becomes the twist, which becomes this, which then goes back to a twist, which then goes on to the bobbin. And it's really incredible the amount of physical and mechanical work that goes into the rope. But I have to say, the thing that impresses me most about your facility and your process is the hand inspection. We'll talk about this and we'll show it either in a separate video or later in this broadcast, but we'll see 1 million meters of rope every month all go through the hands of an Edelrid employee, a physical test that checks every inch, every millimeter of rope. And I have to say, I was shocked to learn that. Shocked and impressed and in awe, really, of your whole facility and the level of technical automation and individual care. It's very, very impressive.
Thanks very much.
Well, thank you so much for opening your doors to us and sharing this process with us. We're going to be here for a few days, and we're really interested to learn more about Edelrid, about some of your other products, production, the management, and yeah, just thank you so much. And I'm incredibly proud, like I said, to bring the legacy of Edelrid and TreeStuff full circle with this journey, and to have you share all this with us.
Thanks very much. Great having you here.
Yeah, really, really great. Hi, I'm Nick Bonner for TreeStuff.com, and I'm here at the Edelrid World Headquarters.
Testing. You heard me say testing. Man, I don't know what's going on here. There we go. Blair, can you still hear me?
I can.
Okay, great. All right, so they were asking about that rope, that green rope there that I cannot actually remember which one it was. The green and black. Do you remember which one that is?
So we've got the Buco and the Woodpecker, and both of those ropes, one's a 32 strand, one's a 24 strand, and those do work great with different mechanical devices. I mean, every device has its own tolerances, so I can't say that they work exactly the same, but you know, you guys that are using these different devices every day know that already. But we do have kind of what we call our green team of athletes. Obviously, our corporate color is green, but more importantly, as you'll learn throughout this webinar, a lot of our ropes do have a sustainability play. So we have one of our arborist ropes where the sheath is made 100% from yarns left over from our normal production. So really cool, the way to reduce needing to purchase additional yarns. But if you guys know, Johnny Corthias, Jared Abergina, there's quite a few folks that kind of utilize our products quite a bit and could speak very well to those. So just reach out to those folks. Kurt the Arborist up in Canada, if you know Kurt. We've got quite a Josiah Georgeson from Strider Tree. So any of these names kind of ring a bell. Megan Bunowski, if you know Megan, she's another one to reach out to. So that's kind of our core team ambassadors, and they can certainly give you a lot of good firsthand knowledge about the ropes.
Yeah, we are going to talk a little bit, or they are a little bit going to talk about sustainability and being green. I don't think they ever touched on the actual green, the Edelrid green certification. If you want to talk a little bit about that now, I think that might be a good time, or we can leave that for a little bit later.
Sure. No, we can. Yeah. So the in 2009, was it 2009? I believe Edelrid converted their entire supply chain on the dynamic rope side. And that's more the polyamides, not the polyesters. We do have some of our work safety ropes that do have polyamide and aren't just 100% polyester. So a lot of our work safety ropes do have what's called the Blue Sign certification. And you can look up Blue Sign, it's all one word. Blue Sign is basically a company that was founded in Switzerland. And they don't manufacture anything, but they're a bunch of kind of material scientists, textile scientists that mapped out a supply chain where textile companies, whether you're making ropes or tex jackets, any kind of a textile, you could utilize these points in your supply chain that have all been approved to meet the highest standard that Blue Sign has. And what they look at is what kind of energy you use, what type of chemicals you're using, what you're doing with your wastewater. And so it just guarantees a manufacturer when they sign on, when they can convert their entire supply chain to Blue Sign, that just means that the products coming out of that supply chain have reduced carbon footprint, reduced chemical usage, reduced water usage, responsible water displacement, etc. So that's Blue Sign. And the rope that I was speaking to that has the sheath made from leftover yarns from our normal rope production is called the Blue Sign. That's a 32 strand rope, excellent rope. And then we also have the Woodpecker, it's a 24 strand. And then we have our XPE, that's a 16 strand.
I believe we have the Buco and the Woodpecker are in the pipeline to be released on TreeStuff pretty soon. So we will be carrying those pretty soon. The Buco is really cool. I think they talk about that a little bit, about how the not recycling works on that. I might get them mixed up, but the reusing of some of the bobbins and fibers and things like that. So we're going to get into the factory tour now. This one's really cool. It's extremely loud in that factory, so I did what I could with the audio. You should be able to hear it. Just hang with me so it sounds a little bit garbled, but we're going to go on that one, and be on the lookout for anything that you would like us to touch on or explain a little bit more afterwards. And here we go.
Hi, I'm Nick Bonner for TreeStuff.com. Welcome to our webinar on Edelrid, their rope production, their ethos on conservation and the environment. And during this broadcast, we're going to walk you through every step that goes from taking raw filament into finished rope product. Martin, thank you so much for having us here. You guys have just a beautiful facility.
Thanks, great having you here.
Yeah, can you tell us a little bit about your position and what you do here?
Sure. I'm the head of the rope development department here at Edelrid. So I'm basically taking care of the new development of rope, but also as we have the production facilities over here, we are pretty familiar with producing the ropes as well. Yeah?
Excellent, excellent. Show us what we have here and tell us what we're looking at.
So basically we have the raw material for the sheath, and this is for dynamic ropes. It's all polyamide 6. And the polyamide 6 is a multi-filament yarn. So if you look at the yarn very closely, you can see that it's made out of very, very much fine filaments. This is roughly around 140 filaments within this yarn, and this is the basis of the material. What you can see as well is that the color is already added. This is done within the spinning process, so the color is within every single filament, and this is the raw material we are using to create our ropes.
And because you buy solution dyed material from your manufacturer, there's no chance of the color wearing off or of seeing white spots beneath the braids or anything like that.
No, the color is within the filament as mentioned, so this is going to stay within your rope as long as you use your rope.
So this material is going to move this way through the factory.
True.
And what is the next step?
So the next step is going to be the twisting step. If we walk over here, I can show that to you.
Great. All right, so Martin, walk us through what happens to the raw filaments and how the twisting step works.
Yeah. So first of all, we have the step of twisting the material over here. And we're doing this for two reasons. First of all, we want to make the material thicker for the sheath material. And second, in the second case, we were just showing the filaments of the yarn. Actually, if you just use the material like this, the breaking of the filament would be very easy. So the rope gets rather quickly worn off. And so we're trying to get that into a structure where the filament is within a structure. And this is why we're doing the twisting over here. So basically we're using the material 3 times, 4 times, 5 times, depending on the rope we want to create. If we're talking about arborism ropes, for example, material can be way thicker. So the thickest construction is like twisting the material 30 times with itself. And so yeah, that's done over here.
When you say twisting, you're talking about just simply twisting it this way, not combining it with another piece.
No, we're talking about adding it 3 times the raw material and then twisting it with itself, so 3 times the material.
Very cool. And all that's happening almost imperceptibly. These machines are moving so quickly, it's hard to even tell that they're moving.
Yeah, they are. So we just have around 80 machines running down there, 80 machines with roughly around 40 carriers per machine. So there's a lot of material you have to set up to get the machinery running. So on one bobbin over here for a production run, we have roughly around 33,000 meters of material. And so this is why we have to run with a decent speed to get the material for all the ropes we're producing.
That's incredible. Thank you so much for showing us how the filaments are turned into a single twist. What's the next step in the process?
The next step, and especially for dynamic ropes, one of the most important steps will be the shrinking of the material, and we do that over there.
Great, well let's walk on over there and we'll see how that goes. Cool. So we've looked at how the rope goes into a twist, and now Martin, you're going to walk us through the shrinking process. Can you tell us why a rope is shrunk?
Shrinking process is one of the most important steps we're doing over here, especially for dynamic ropes, because we were talking about the raw material. It's polyamide 6, which is roughly having an elongation about 25-ish%, depending on the material. But this is not enough for a dynamic rope, so we have to shrink the material to get more elongation into the material, and in order to create a really dynamic climbing rope.
Interesting. What are we looking at here?
So we're looking here at the 2 components of a rope. So this is the core material, and over there we're seeing the sheath material. And also one reason why we're using polyamide is because polyamide does love water, and this does make the material shrinkable. So this is what we're doing over here in this machinery. Basically this is like a steam cooking pot your grandmother might have used. So this is what we're doing over here. So we're just steaming the material with hot steam, water steam, and this is making the material to shrink. In order to do that and to have it the same amount of shrinkage for all the material we're using, we have to create a structure within the textile that the steam can flow through very evenly. And so for the sheath, we have to do this step over here, which is a knitting process. And we need this process in order to have a structure where the steam can flow through the whole material, shrinking it even over the whole process.
So the question that immediately occurs to me is, that looks more like a scarf than rope. Rope's not large and flat like that. How does that material turn into rope?
Yeah, unfortunately, this step has to be done for the shrinking. And after the shrinking process, when we have the elongation in the material, we're just pulling the yarn out and then rewinding it to the carriers for the braiding machines. And this is done over there.
So a manual is the wrong word, a mechanical weaving process is done and then undone simply to facilitate a more even shrinking.
Yeah.
Looking at this is after and this is before.
True.
And you can feel the difference. This is a little softer and this is a little stiffer.
Yeah. You mentioned it, you can feel it, and actually you can see it. So before the shrinking process, the coils are more or less running to the bottom of this carrier wagon. And if you see it afterwards, we're shrinking it roughly around 20-30%, depending on the material, and you can quite quickly realize. And during the drop, actually in a more easy way of explanation, you can say what we're shrinking into the material. This is in combination with the elongation of the material, the 40% of elongation we get during a drop with a dynamic rope.
Wow. Is there a difference in the weight before or after?
Not really. So if you compare the weight of the whole coil, but if you compare the weight of, for example, a meter of twisted core, then for sure the weight would be higher due to the shrinking of the material.
When we look at this core here, there are 3 twists inside of here?
Yeah, so compared to the sheath material, what we're doing for the core, this is a double stage twist, so we have 2 twisting stages. If you look at this closely, the first twist is like the sheath material. So the material is twisted with itself 5 times, 6 times, 7 times, depending on the construction. And then this twist is used to twist it again in the opposite directions, in this case 3 times. So this is a 2-stage twist, so we call it.
Thank you so much for sharing how and why rope is shrunk for industrial and climbing applications. What's the next step?
The next step would either be, if we are talking about treated ropes, the treatment of the core material, or then setting up the material for the braiding machinery, so basically rewinding it on processable applications for the twisting process.
Okay, well, let's walk over and check out those steps then.
Yeah, sure.
Great.
Let's go. So in order to achieve the actual standard currently, so the UIAA dry treatment standard, we have to treat the core of the rope first, and this is what's going to be done over here. So treating textiles, it's always an uptake of chemistry and then trying to fix this chemistry by a temperature over time. And this is what's basically done over here. For every core strength first, then we're bringing it to the braiding machinery, braiding the rope around this already treated core, and then dipping the whole rope through the chemistry again and fixing this chemistry on the whole rope.
So my understanding with basically anything related to chemistry is that it's not so hard if you don't care about the environment. And this is going to be something that we're going to touch on in some of our other videos and in our Edelrid webinar. You guys are not always taking the easy way.
No, we are not, and taking care of the environment, especially for dynamic climbing ropes. I mean, we all love nature. This is why we're doing the climbing,
right?
And so this is a big part of the deal, isn't it? Nonetheless, you have to say, technically, and this is how the treatment was done for years now, we still do use an NFC chemistry, which is, if we only talk about technical aspects, water uptake, this is the best solution you can get. Nonetheless, you will mention it, we don't believe it to be the way to go for the future, so we committed ourselves to get rid of the FC treatment, and we're working on we already have an FC-free treatment, as we call it, eco-dry treatment, which is passing the standard as well, but you have to be aware that the downside of this is that it's not going to be as good over time. Nonetheless, we do think it's the way to go for the future.
And what is the requirement for the testing?
The requirement for the testing is, so first of all, within the test, you create abrasion to the rope, because like doing it with a new rope, it's rather easy. So the first part of the test is creating abrasion to the rope. And after this, the rope is put to a test, and you're flowing water by the rope, and you measure the weight before and after the test. And so the requirement you have to get is the gain of weight due to water uptake has to be less than 5%, which is pretty tricky. So if you would use an untreated rope, you put it on the test, almost after 2 minutes, you would have an uptake of 40-ish%, 50-ish% of water. Yes, polyamide does not uptake 50%, but the water sitting in between the core strengths will count as well. So this would be for a non-treated rope. So achieving less than 5% is pretty tricky, and this is why we have to start with the core strengths in itself to dye them first and then create the rope around it.
You mentioned that polyamide loves water,
Yes.
and that's why we do these dry treatments on polyamide or nylon type products. Polyester, does it require the same type of hydrophobic treatment?
It would be good to treat it as well, but yes, this is one fact why polyester is used for application which are not that dynamic, or one of the reasons, and this is that the water uptake of polyester is way less than with polyamide. Nonetheless, treating polyester could be interesting for certain applications as well, where you know they are in contact with a lot of water.
Interesting. That 5% must be hard. I think if you hosed me down right now, I would weigh 5% more, just from what my clothes carry.
Yeah.
Martin, can you talk us through exactly what we're looking at here mechanically?
I can. So basically, in order to keep the process running the whole time, due to having temperature over here, the machinery can't stop. Due to the temperature is going to affect the material as soon as it stops within the machinery. So we have to have material here in order to change the running material in case this one is done, so to set up the next one. So this is just like basically storage of material. Then we have the dipping, so the uptake of the chemistry in here. And then as mentioned, what we have in over here is heat treatment over time. So this basically is just a temperature chamber. First of all, we're trying to evaporate the water within the solution, and then the fixation of the chemistry does start. And over here, we're just rewinding the material to get it into a way so we can process this on the braiding machinery afterwards.
So far, we've already seen so many steps where you're taking the material, assembling it, deassembling it. It must feel very repetitive sometimes, but it's really incredible how many things it goes through, and we're not even halfway through, it seems like.
And if you watch the layout of our production facility, this is what's going to happen. So the whole top floor over here is just like setting the material up in order to make the braiding downstairs. So you always think about rope production as the braiding, and this is a hugely important part. But the same amount of space we're using for the braiding is up here. We're using the same amount of getting the material ready for the braiding.
Martin, are you able to demonstrate the effect of this dry treatment for us?
Yeah, that's pretty easy.
Great, let's take a look. Martin, walk us through the effect of the dry treatment here as we can see it physically.
Yeah, pretty simple. So this is a non-treated polyamide. We said polyamide does love water. So if we just add a few drops of water over here, what you can see is basically not much because the polyamide is uptaking the water so quickly. Over here, we have a dry treated core material. And if we do the same thing over here, what you can see is, first of all, the water is staying on the surface, so the polyamide is not uptaking it. And if you just turn the material a little bit, the water quite quickly will run off. So this is the repellency effect we were trying to implement, and actually it did quite work out well, I would say.
Can you put those 3 drops back there for me?
Yeah.
Kale, come over here. I'm going to try to blow the water towards the camera. Okay, that was pretty cool. Can you give me like a line of, give me a line of water? That's pretty impressive.
It is.
What's the next step in the rope production?
Unfortunately, we still need carriers for the braiding machine for the sheath material. So this would be the next step in order to get one step closer to the braiding machinery.
We're going to unwrap it and wrap it again.
Absolutely.
Okay, well, let's just take a walk over and we'll check that out.
Yeah.
Martin, this material looks familiar. We saw this being knitted on the machines earlier. What's happening here?
Yeah, unfortunately, we can't process the material like this on the braiding machinery. So we have to do a rewinding process again in order to get it on the carriers for the braiding machinery.
That's great. For some reason, I just like the way it looks. It looks kind of silly to me. And check this out, everybody. I've got a new neck gaiter, huh? Let's see. do you think? Does that look good on me?
Awesome.
I think that this could potentially be, you know, a fun like swag product for you guys. You mentioned that you do upcycle some of the pieces that are too short, but some like this are too short for anything, correct?
Yeah, true. Some are too short, but as mentioned, we're trying to use almost all the material due to financial and for sure eco reasons. And this is where the BOA Eco, for example, is coming from. So if we rewind the material, all the bobbins we're using or the carriers on the braiding machine has to be the same length. So if we would create one carrier being less long than the machinery would stop, and we had to chunk away all the other carriers, which is no sense at all. So what we're doing, if we have left over here, which is long enough to create a bobbin or a carrier for the braiding machinery, but not as long as the normal production length, we are using this material in order to set up the BOA Eco. So these are carriers with different lengths, then we're trying to cluster them in weight. And so this is why the rope does look different all the time, because we're using all the leftover material to set up the carriers, and then all these leftover carriers are put onto the braiding machinery in order to create the BOA Eco.
The only question I have is whether Blair was going to call this the Edelrid Eco Gator or the BOA Gator, or the BOA, or the Eco Scarf. Ooh, I like that, Blair. Eco Scarf or Eco Gator? I think Eco Gator because it goes with BOA, right?
That sounds good to me.
The Eco Gator from Edelrid, coming to a store near you soon. Martin, what's the next step after we've unknitted these materials? Can
Sure.
Let's take a look at the machine over here. So we're on the other side here, and we see these are actually being unknitted and then wrapped onto the bobbins.
Yeah. So a braiding machinery is mostly defined by the number of carriers running around. So, and the most used machinery at our facility is 40 carrier machines. So 20 carriers running clockwise and 20 running anti-clockwise. And this is the carrier. We are putting the sheath material onto it. So roughly, if we're talking about one production run, this would be around 1,500 meters of sheath material, which is creating 1,000 meters roughly of rope at the end of the day due to the angle of braiding. This is the production run length is a little shorter than the material we put in onto the carrier.
I noticed that some of the bobbins are red and some of the bobbins are white. Is that to signify the difference between the S and the Z twist?
Absolutely, that's it. So we have to twist the material one time clockwise and anti-clockwise, depending on the way it's running around the braiding machinery. And yeah, the color does differentiate the twisting direction of the yarn.
And this machine, it only does red bobbins, and this machine only does white bobbins, it looks like.
Currently, it's the way it is, but it can be set up different as well. Yeah.
Great. What is the next step after this?
Yeah, next step, we finally made it to the braiding machinery, but this is done downstairs.
All right, well, let's take a look at how the braiding is. We'll walk downstairs and check it out. Martin, this is a rope braider, huh?
This is a rope braiding machine. Finally, we made it down here.
I'm excited to see. Walk us through how the rope braiding works.
So actually, rope braiding machinery and the technology is pretty simple, I would say. So we have a main motor driving the machinery, and then we have the bobbins running around here. And we have different ways of setting up the machinery. So in this case, we have a 1/1 braiding. So if you see this pair of material, it's just running over this pair of material, and then below that one. So what we're creating over here is just a 1/1 braid. So
And we can see this bobbin that we started looking at is actually traveling all the way around.
It's driving all the way around. Half of the bobbins are driving around clockwise, and half of the bobbins is driving around anti-clockwise. And on this braiding machinery, we have a lot of options to get a rope to be a good rope or to be a rope we as Edelrid think this is an Edelrid rope. So for example, if you look over here, there's a brake former. We wouldn't need that, so actually the braiding would happen automatically. But in order to control that, we control the height of the braiding point. As well, we do have a spring over here, and the spring is responsible for the tension to give free the yarn on the carrier. If we change the spring in here and the spring load in here, we can change the amount of core material we are pressing into the rope. So if we're pressing a lot of core into the rope, it gets very pressure stable, the rope. As well, we do have a gear over here which is transmitting the speed of the carriers to the gear which is making the uptake. So if we change the gears in here, we can pull the rope through rather quickly. And this is giving a very loose blade, and this is very bending unstable in the rope. If we're braiding it very close, so slow, putting out speed, then it's going to be very stiff concerning the bending stability. And so we have a lot of factors over here we can work through and apply to get a rope the way we want to have it.
And it sounds like as much as it's technical engineering and planning, that it's also a little bit of like trial and error, kind of like a measure carpenter versus a trim carpenter.
Yeah, sure. I would not say it's trial and error. I would say it's knowledge we have in here. No, but for sure, it's a bit of trial and error. So first of all, if we start a development, we think about things we want to change. Then we think about the material we want to use to achieve this change. And then we come to the braiding machinery. And yes, we do have a lot of experience out of our 160 years history, but still we're setting it up. Then we do the testing, and then we're coming up to change factors in the braiding machinery as long as we feel confident with the rope and we're passing all the tests we have to pass.
And a really interesting fact is that this melding of the current and the mantle, Edelrid invented that.
True, we are the first brand which came up with this idea, and I think this one thing which is within our DNA. So we try to think outside of the box to stay inventive, and I think this is what's driving us within this company.
Very interesting. Walk us through what's happening up here at the top.
So as mentioned, this is mostly the driving wheel, which is pulling the rope out of the braiding. And as mentioned, if we speed this up, we get a loose braid or we get a very close braid, and this is determining the bending stability of a rope.
Great. Can we walk over and look at one of the machines in action?
So
let's do it.
Okay, so this is what actually happens in full speed. So what we're doing over here is the output of the machinery is roughly 1,000 meters per 24 hours. And this is why compared to what I just showed you, actually you can't again really see what's happening because we have to run a certain speed to get the amount of material out of the machinery.
Looking at the top here, is the rope going like this or is it actually rotating?
No, it's just a little bit moving from left to right. It's not twisting at all, but this is just due to the uptake.
This is a really incredible machine.
So this here would be a 48 period machine.
It's hard to tell that the bobbins are moving around. It almost looks like they're just interchanging.
And you get really used to it if you're working a lot of it. So we would be in a position to really follow a bobbin. And then, for example, you have to be very careful about the color pattern, because if the first and the second bobbin are going to run across, and then the color pattern is going to change. So before setting up the machinery, you always have to take care of that the bobbins are right and that the yarn is not running over another. And so normally if you start working with the machinery, you really have to do it in slow pace. If you have the people working in here for years, they just can see like on the full speed of the machine.
Martin, thank you so much for sharing how the braiding machines work. Can you tell me what the next step is?
The next step would be for dry treated ropes. We only have the core treated up until now, so we have to treat the whole rope in order to get the sheet treated as well.
So Martin, this has got to be the biggest spool of rope that I think I've ever seen. How many feet of rope are on here?
Yeah, so actually one production rope of one single rope would be roughly 1,200 meters, and this is 7 sets of rope. So yeah, you can quickly do the math, and you got a bit of rope on that carrier over there.
3 miles, Cale. 3 miles of rope on here, and it looks like there's actually more than one rope on there.
True. For the treatment of the sheet, we can run different ropes through the machinery, and so this is what's going to be the storage for the treatment of the sheet material.
Great. So the rope goes into the machine here,
Yes.
and then it's going to be dipped into the chemistry over here.
Yeah. So basically, what's happening over here is more or less the same process like we do in upstairs for the core material. So treatment is always uptake of chemistry and then heat over time, and that's what we're doing here for the finished braided rope. As the core is already braided, this will always the uptake will only be done by the sheath uptake and then thermal treatment over time.
So the rope is comes off of the spool, goes through the chemistry, and then is stretched and heat treated and dried out. Very
it.
cool.
And then you get a fully dry treatment rope passing the UAA standard.
Simple.
Simple.
Simple. Easy. You can do it at home. I could make a rope.
Easy.
Martin, thanks so much for sharing how the rope is treated for dry treatment after it's produced. What would be the next step in your production line?
So the next step in our production would be, unfortunately, not a lot of customers are interested in buying 1,000 meters of rope. So yeah, then we have to do the cutting down of the rope, essentially, or basically, and yeah, I will show you one important step before we do the cutting as well.
Great. Well, let's walk over and check it out. Thanks so
Cool.
much. Hi, I'm Nick Bonner for TreeStuff.com. I'm here with Martin at Edelrid World Headquarters, and I am proud on behalf of the Edelrid team to share this step of the rope production process with you because I think it's incredible. Martin, tell us what we see here.
Yeah, what we see over here, before we are cutting down the ropes into selling length, we are doing a hand-eye test check of every meter of rope we are producing in yield. And this is what our colleague Dashery is doing over here. She's running one full set of production length through a hand.
Every meter, every day, 1 million meters a month, hand-checked by an Edelrid employee here in Isny, Germany.
True.
That's mind-blowing.
Yeah, it is, and we try to make this automatically in order to be more efficient, but we didn't find any kind of optical solution, technical solution, mechanical machinery solution, which is as good as the employees over here. They are so used to doing it. Yeah, no machinery does match the quality of the employees over here.
So Edelrid quality is truly a combination of both German engineering and personal experience, and really personal touch, a hand touch. I gotta say it again, 1 million meters of rope a month runs through the hands of an Edelrid employee and is individually checked before it reaches tree climbers, rock climbers, tower technicians, turbine technicians, all across the world.
Yep.
If there isn't a better reason to feel good about buying a product and feel safe putting your life in it, I don't know what is. I'm blown away. You should be so proud of yourselves and your commitment to both safety and quality. It's really incredible.
Thanks very much.
Yeah, thank you for sharing this with us. Once it goes through this final quality check, the next step is actually an electronic check, right? Where there's the electronic tape, and we're going to walk over there and check that out and see the cutting and packaging, ultrasonic welding, all that.
Yeah, let's go over
Great.
there.
Martin, walk us through what we're seeing.
Yeah, so what we're seeing over here is basically the cutting through the length we want to have, the middle marking, which is just currently done, and processing of the rope to the next step. If we find defects or anomalies to the rope, for example, during the hand check the process, we're using some metal tape to this spot the rope and then cut it out. Rapidly going to fit, and then the next rope is going to be processed. Let's see one with the short now, place the box, and then we're processing it to the next step of welding down the end of the rope in order to make sure that the 4 inch sheath can be to with the rope. Okay, so what we're seeing over here is one end of the rope is already cut. It's placed outside the box in order for the next process step. So the first half of the rope is now being processed into the box. As soon as the machinery is going to stop, what we can see over here, the robot arm is taking the middle piece of the rope, which is going to be marked now. During the process of marking the middle. The second half of the rope is already processed into the box, and in order to not have a few different marks on the rope, we are placing the middle marking outside of the box in order to give it time to allow the painting time to dry up. Now the second half is already processed to the box, so the rope is cutted again, and the second end of the rope is placed outside of the box as well in order to do the next process step, and then it's processed further down the production.
Martin, tell us what's happening in this step.
Yeah, so in this step we want to melt the core and the sheath material at the end of the rope together. This is done via ultrasonic welding, and this is in order due to during usage it always can happen that the sheath and the core is slipping a little bit, so the core might come out or the sheath might slip over the core, and in order to avoid that we're welding the material together, so this is not going to happen within the process. As well, we do see the labeling at the end of the rope. This is done over here, so diameter, scenario of usage, manufacturer's length, and all the stuff you need to have on the end label of the rope.
What are the differences between ultrasonic welding and using a hot knife, and what are the advantages or disadvantages?
So using the hot knife, we're using it for cutting of the rope, and this is melting the material just on a very, very short length, so maybe half a centimeter, even less, I would say. And the advantage of the ultrasonic sound is we are melting it on a way longer length, and we're compressing it really to the end. So this is a very tricky form of, or a very stable form of melting the material together.
So the hot knife melts the end, and you're actually melting an inch or so of the rope through the entire core.
Yeah.
I had no idea. That's very interesting. Well, thank you for sharing how the rope is cut and measured. Let's take a look at how packaging happens.
Yeah, sure.
So Martin, why is this machine twisting like this? Why not simply just wrap the rope up?
Yeah, all the older climbers might know that. So back in the days, rope was just like coiled like this, only one twisting direction. And so in order to use the rope, you had really be careful to decoil the rope, otherwise you would have like twists within the rope and it would be really a mess from the start. So what we're trying to do, or what we're doing over here, if we twist it once around this axle, we're twisting it around the other axle as well, and this is in order to get the coil actually in the rope first, so that if you just put it on the ground and pull the rope out, you're de-rolling these coils we put in, these twists we put in, and then it's ready to climb.
You know, Cale, you may have to overlay me coiling a rope because that was way faster. But in our rope coiling video on TreeStuff.com, you can see we actually recommend using your thumb to impart a twist as you hand coil for that exact same purpose, so that as you're taking it off, you're unrolling that twist each time.
Yeah, and so that's what we're doing automatically over here.
It's pretty neat. I feel validated, I'm not gonna lie. I appreciate you showing me a gigantic robot version of a person coiling a rope. We see he's wrapped the rope up here now. The next step will be what?
Next step will be just packaging the rope, getting all the labels on, getting all the information in. So yeah, it's going to be just bundled over here in order to keep it in shape. Then, as mentioned, we're given all the information needed. What we're doing over here is again a safety check. So we're measuring the weight of the rope, and if it's lower or higher than the recommended weight we have stored in the machinery, then the rope is not going to be sold, and we will check all the process why we do have a weight difference. So this is the last gap. Safety check as well over here. And yeah, then we're going to package, ship it, and then it's ready to climb.
Martin, thank you so much for sharing all of the processes that go into simply cutting, measuring, and doing multiple final quality checks on the rope. I'm really amazed at how you have combined the human touch with such a high level of automation and technology. It really speaks volumes to the quality that you have established here at Edelrid.
Thanks very much.
Yeah, thank you so much, and I think that's it. We're gonna have more Edelrid ropes in the store soon, and you'll be able to find those at TreeStuff.com. Martin, thank you so much, and I look forward to the next part of our conversation where we're going to kind of just talk about the ethos and all the thought process that goes into rope making.
Thanks very much.
Thank you. It was a pleasure. Hi, I'm Nick Bonner.
All right. I hope everyone enjoyed their little trip to Isny, Germany there. That was a rope tour from the man himself, Martin Schlemmer. Awesome dude, extremely knowledgeable about ropes. And there we go. So a couple questions here. Blair is still he's West Coast, so he's still at work right now. But I will try to answer a couple of these things here for him. There he is. Blair, do you have... we've got Christopher Van Gerp asking recommendations on rope cleaning and maintenance from Edelrid.
Right. So in terms of, washing with some kind of chemical, of course, we want to find something that's pH neutral, not too acidic, right? We don't want to break down the fibers in the rope. Obviously, you don't want to wash those in, really hot water. So typically cold water, pH neutral, soap for cleaning, and then, put outside, not outside, but probably the garage is a better place, something away from UV. You don't want to have it out in the sun to dry, which is kind of counterintuitive. So it can take a little bit of time, but even just in the house, when I clean my own ropes, I have a product that there's a couple of rope manufacturers. We've made them in the past. We don't personally make one right now, but there are companies that make rope cleaners. Bial is one.
Mm-hmm.
They have a rope cleaner that I've used, and then I typically just wash them. It's in my washing machine at home, and then I
throw them in a mesh bag and
then leave them out to dry on the side of the house. And I think it is important to daisy chain them too before you just throw them in. If you just throw it in the washing machine, it can get all twisted up. So I typically daisy chain mine first.
Also, that helps with the same reason that in the rope factory that they're taking all of that nylon and braiding it into that scarf before doing that shrink. There is that everything, if you tightly wind everything up in a rope, then you can only get to that outside area. So that daisy chain is kind of the same thing they're doing with that, so that you can get all of the moisture and the cleaning supplies to it. The other thing was, and I don't know who it say. Yeah, it was Gary. Gary Thacker was asking if there's any inclusion coming up with inventory management products like Scannable with the ropes in Edelrid's production line.
Sure. Yeah, that's a great question. So we work closely with the Scannable folks. I believe they're out of the UK, right? But I know we do have
New Zealand, I think.
New Zealand, yeah.
Mm-hmm.
That's right, New Zealand, yeah. But I know that we do work closely with those folks. We currently do in most of our life safety products, like our rope access harnesses, the tree Rex. Actually, you'll see on the back of the tree Rex. This is actually our Tree Raptor, one of our new products. So you can see here it says RFID. So most of our life safety products like this now do come with a transponder already embedded in the product. And as long as you have a UHF reader, then you get that and automatically input all the product information that was put into use and been assigned to when it was affected last. So that is something that I think we're a little bit ahead of the curve when it comes to manufacturers. And then on the rope side, it's a little bit trickier, right? Because you've got to somehow embed that transponder or use an adhesive. And so I know that is something that's that we do have now in terms of our own in terminations that they offer in Germany. It's not something that we offer here, but it's a great question, and we are moving in that direction, and we do see the opportunity for it, especially for the big companies.
Yeah. Cool. I think we're going to go straight in. Sorry. We were going to talk about this beforehand. So the Tree Raptor, they talk about it a little bit in the product development section that we'll be playing in a couple minutes here. But the Tree Raptor is kind of based off of the Tree Rex harness system. We'll have a bunch of videos about that coming out soon. It's a great harness. It's a great price point. And they're going to talk about that a little bit more. But we have a special sweepstakes that's going to be coming up. I'm going to be announcing soon on social media and through email that we are doing what?
So we are going to be giving what we call kind of a first to consumer experience. So the Tree Raptor comes out mid-April, which means I'll get my first C container of those products towards the end of March. So with TreeStuff, we're going to partner, do a giveaway. Whoever wins, we are going to ship them a Tree Raptor harness before we ship it to TreeStuff, or to Cheryl Tree, or to our possession. We're going to do 2 of them.
2 of them.
Right? Yep. And so this is the harness here. It is, like Kel said, kind of similar to the Tree Rex harness. It does have our triple locked buckle system here, which is super easy to manipulate. Just goes right in, comes right back out. This one is unique. It does have a feature that the Tree Rex does not have. It does have this VCR Velcro strap here, so when you are putting it on, it kind of holds itself into place. Then you can kind of cinch down the buckles and get it really customized to your body. It does come with everything that you see here. So it does come with the 2 different rope bridges here, the ring, it's got the paws in the front, the D's on the side. It does have the breathability that the Tree Rex has, the padding, really light harness, and fully featured. It's got the rigid gear loops, which people love about the Tree Rex. About the only thing it doesn't have that the Tree Rex doesn't is the SRT attachment point. So super excited. The retail on this is going to be about $429. So it's a great value. We're going to give 2 of them away first for that first to consumer experience. So make sure you pay attention to when Kel launches that.
Great. All right. Well, we are going to go into the awesome 3D printing lab in Edelrid, talking here with Elena. Yeah, very cool. And then we will go straight into product development from there.
Hi, I'm Nick Bonner for TreeStuff.com, and I'm here with Elena. That was our third take. Look, this is Edelrid's 3D printing lab. Awesome. Let's take a look. Elena, tell me what all these machines are doing.
They are all 3D printers. We have 4 3D printers in here. These 2 oranges one, and the big microwave behind there. And mainly those machines are helping us to prototype pieces and find out about shapes and details before we get into toolings and in production. Of course, those are all polymers machines, so we can't prototype anything out of metal in this little room. But the idea is that anyway we can check together shapes, that the pieces are going along together, they're fitting, that they are good to be held in hand. And then we can go on with further metal prototypes in production.
I have a filament deposit printer.
Mm-hmm.
What is that? That's what this is.
Correct.
So we're using plastic filament here. What are some of the other printers? This one looks different. Can you explain the orange one to me?
Yes, those 2 are quite similar to each other. They are both resin printers, which means there is a bath of resin underneath, which is a liquid monomer, and then there is a strong light underneath. That's the easy way.
A strong light.
A strong light, the UV light or a very strong light beam. And basically, the bottom of this resin tank is transparent, so the light can get through and can polymerize the lower layer of monomer. And then the platform, it slowly move upward, and by moving upward, it gets little by little all these layers of polymerized material. And the good things of those printers is that the resolution is so much higher than this one, so you don't see all the little lines that this normal printer have.
Can we take a look at these parts? They look like they're finished.
Yes, well, almost. You can come in here. So this, for instance, I'll need gloves because it gets very sticky. You see the things are actually printed the other way around compared to a filament printer. The filament printer goes from bottom up, and this resin that goes from up, they pull the thing out really of the tank. And in this case, we have a carabiner there. It's not totally ready. So we have
Oh, there's a unicorn here.
we have it under control in here. It's all okay. It's all okay. Just ignore him. No one else is seeing him. Actually, he's not there. It looks like this. So it's not exactly ready yet. What we need to do now is that we need to remove it from the support. And then at this point it needs to be washed because it's still, you see, it's quite sticky. And after it's washed in alcoholic solution, actually, it gets into a further round of UV light all around, so everything that is not totally polymerized, it will get polymerized and hard. And you see the resolution of this stuff, you really don't see all the little lines that you would have on a filament printer.
Before you had this 3D printing lab, how was this type of prototyping done?
With a lot of patience in the workshop, basically.
Were you making the models out of clay or wood or sending them off for CNC?
There were different stages. So in the last years, before we could have a 3D printer in-house, there were already some companies that were offering 3D printing services. So we were sending the pieces out, but of course it was very expensive and it was time consuming.
Right.
So there were some years like this. So before this time, we were spending a lot of time in the workshop, basically. Means making prototype out of plastic and either drilling them or cutting them by hand, a lot of sandpaper, a lot of Dremel work. So it was just more time consuming. But it's still what we are doing nowadays for quite some metal pieces. I mean, we can still CNC cut metal pieces, but it takes time to make the 3D and send them for CNC cutting and then take them back. So sometimes we just, for the easy pieces, we do them by hand.
Interesting. What is this part behind you? This looks very complex. What are we looking at here?
This failed.
It failed?
It's just to say, we are not yet on a level where we could just push the button and then get things out. So it works quite all right, but it's not like this 100% yet. So sometimes the prints fail, especially this printer has the capacity of printing soft material. So, that's still sticky, sorry.
Wow, is this like the last for a shoe?
Yeah, it's kind of a piece of a shoe. So this is still soft, and it's something that the other printers can't do. But as well, printing soft material, it's a bit borderline. So
is
sometimes
this a TPU material?
No, they are not TPU because TPU are thermopolymers.
Which require heat.
Yeah, they are formed, like you can heat them and melt them, and those are different. Those are stuff that have some chemical additive in order to react with UV light. So that's not the family of TPU. They can behave sometimes similarly.
Interesting.
But that's not TPU.
I print with TPU at home. I can tell
TPU you can print with these actually. But then again, the quality is quite, it depends which shape you're making, right?
Yeah, right? Yeah. Absolutely. Or if the shape goes like this or like this.
Yeah.
I can tell you're really passionate about this. How long have you worked here at Edelrid?
Oh, 9 years by now.
Yeah, and what are some of your favorite projects that you've worked on?
Ooh, the one I can tell. Let me think. I mean, I loved a lot the the car project.
The car project?
The pulley system.
Yeah.
You know the tape pulley system?
Yep.
This came out from the innovation department because the process was a bit, okay, we got the idea of making a pulley system out of webbing instead of out of ropes. And we were like, yeah, okay, does it make sense? Is it like... And so we started producing the first prototype and checking them out and testing. And then eventually it was like, yeah, actually it could be cool. It can become way more compact than the current pulleys. And then we figured out, well, we can even have a system so you can release it under load, which you can't do with the normal rope pulleys.
So wait a second. Oh, you're saying the car, not the car.
Yes, the car.
Okay, so that I was thinking you were talking about, because I know that Edelrid makes the convertible roofs.
No.
And those are the convertibles, but those are made with cordage. I was like, right. And I was going to ask, is this where the car pulley system came from? The car is fabulous. I love how compact it is, and also when you're using mechanical advantage, you want to like give it some oomph, right?
Yeah.
And that hurts when you're putting like a small cordage. So like, I think the objectives of a project like that are kind of at odds with each other, right? Like make it super small and then it hurts to pull on. Whereas with the Ka, it's nice and flat. You made that.
Yes. Yeah, I mean, together I was not the only person working on it, but it was mainly my project.
There's a lot of different products from different vendors in that class, and I think that the Ka is absolutely like the standout. It's simple, it works under load, and I also like the way when it collapses and it expands, the webbing doesn't twist up.
Yeah.
It lays much more flat, and you don't have to deal with the kind of, like when you set up a set of fours, where it eventually one of them has to twist around itself, which just kind of makes the whole thing want to go like this.
Yes.
Really, really nice project.
Cool, thank you.
Congratulations. What was the biggest, the most frustrating and disappointing project you've worked on?
Oh,
in your time here?
It was a project that was called Edelrid, which was based on a kind of a cool concept idea. Actually, it's a project I inherit as a concept from the person before me, and I brought it forward and forward. And it was a very, in a way, cool piece because there were two pieces that were stuck together and were rotating into each other. So in a way, it was really, really cool. But it was a production nightmare. So actually, we went on for years trying to make it work in production, and eventually we gave up because it was like, that's enough. Now we need to stop.
So was that a happy moment or a sad moment?
Actually, when at the end we said, okay, gone, it was quite a happy moment. But
Bittersweet.
you know, all the steps in between in which you get the pieces and you try to put them together, it's like, no, again, no.
I can imagine how frustrating it must be to let something go, but also a relief.
Yes.
Anyways, thank you for sharing this wonderful lab with us. This is really cool technology, and I think tree climbers and climbers of all different types and structures are really lucky to have people that are so passionate and so knowledgeable here at Edelrid, and also the unicorns.
Right,
Yeah.
of course. There
Thank
was
you.
no unicorn, by the way. You were the only one seeing it.
Hi, I'm Nick Bonner for TreeStuff.com, and I'm here with Elena. That was our
That's
third.
me.
That was our third take. Look, this is Edelrid's 3D printing lab.
Obviously,
Awesome.
a rope development team. We got a hardware development team that is everything with metal and plastic. Then we got a shoe development team for our sports side, apparel development, and then textile apparel development, which is everything that is not a rope, a shoe, or clothing. And then the product management team is the sixth team in my department that then does the commercialization within the company and then to external. So I'm with the company now for 9 years.
I'm Daniel. I'm with Edelrid since 2006. I started in the development team to grow the development team. When I started, there was no development. I was the first developer that Edelrid had after 2000, and now I'm doing the innovation department. The idea behind this department is that we found development projects, they're plannable, they have to be plannable. So you know, in case you develop a new carabiner, you can plan how long it will take for tooling, how long it will take for prototyping, certification. So it's a plannable process. But whenever it comes to innovation, so you want to try new concepts, it's not plannable. You don't know when the concept will be working, when you will be finished, when you will have the final idea for the product to be perfect. So it's an unplannable process, and that's a disturbing factor in the development department, because there it needs to run or
Follow a Gantt chart.
Exactly. So we said we exclude all this conceptual work out of the development teams and put it into a separate team that is doing something like a research and pre-development. And as soon as the product concept is finalized, it goes to Phil's development department, and then the industrialization phase starts.
That's very interesting.
That's my job.
When you guys start a project, so for example, when you start an innovation project, what are some of the first steps that you go through? Like thinking about harness innovation, for example.
It's always a bit depending from which direction the product development starts. It can be that we have a clear requirement from sales, and sales forwards this to product management. It says, hey, we need a new harness in that kind of application. These are our requests to the harness. This is the price point that we need to meet. This is the sizes that we need. This is the certification that the harness has to bring. Then it's a development that starts from the market through product management, given to development. It can also happen that it starts by an idea. So that we say, "Ooh, why everybody is doing it that way? It's way cooler." So it's just an idea. So we start with a rough idea, and then start development from the idea, and try to bring a product and fit it into the collection and into the range. Then the direction is it's totally the opposite direction. Then the product is done in innovation, works through product management, then into development. And so it's a different approach. In case you have clear requirements market-wise, then it's rather easy because you more or less just follow a spec sheet.
It's easy.
It's easy because the spec sheet is always the same. It has to be lighter, faster,
more beautiful,
cheaper, more beautiful, better, less consumption,
more durable,
no waste, no effect on the environment. So the spec sheet is more or less always the same.
Like what Daniel said is an interesting point. Like sales is for sure in one source, but there are also very technical sources. Like we sometimes have it that a standard changes and there's a new requirement that makes that we need to pass now, and so we need to change the product because there will be a new standard in the future. Or we have production issues with certain things on the product that the production says, well, this is a nightmare every time I get this. And there's like super high inefficiencies with this product. So then could also be the start of a development project. So there are very many sources where it can come from.
Have you gotten a development project from Daniel and been like, no. Like, no. Send it back. Send it back. This is crazy.
Well, I mean,
do you ever send him back, or are you ever like, no, man, come back again tomorrow?
I mean, maybe in a way, but I mean, the situation is not that we come to work every day, and then one day Daniel says like, I open the curtain, and here's the product. So there's obviously a lot of exchange going on between the departments.
Usually when the idea is there, the exchange starts already. We would never start. No, every now and then we keep some surprises. We have crazy ideas, so we keep it for us for a while until there is something to present, and then it can happen that we say, oh, look what we did. Last 6 months we worked on this, and see, it's there. This we do if we know that it will work, that it will be a cool product, that we will have use for this product. But the point is also that we distinguish a bit in our product range. There are products that we need to earn money with, that you have to have in the collection, in the range, have to be there. It's inevitable. And there are products that we more or less allow ourselves to have. We know it's
the top of pyramid stuff.
Exactly, the cool stuff that we want to have for ourselves, and we already in the beginning know this will not be like the portaledge, for example. It's not a turnover product. It's not something to earn money with. It's something we wanted to have. We played on it. The options was there. The cool idea was there. I say, okay, why not to do it?
It's the best way to sleep in a tree.
Absolutely.
I've camped in a redwood and a sequoia on a portaledge. The best.
We just when we were in the teaching it's 2 months ago or so, it's like sleeping like baby. Yeah, I love it.
Compared to Edelrid's 150-year history, 160-year history, excuse me. I knew I was going to get that wrong. Compared to the 160 years in history, there's a ton of milestones, right? First kern mantle rope, all sorts of different innovations. The entry into tree care is relatively new for you, within 10 years. Yes?
I don't know when. I think through the ropes, we've always been, right from the beginning, Edelrid was always a bit in this business because like it started.
They were using the Edelrid ropes
40 years ago, and the Edelrid ropes, they've always been there, and so there was always a bit of a link. But like a real step into this market and specialized product for this market, this is not that old. Yeah.
Interesting.
And I don't remember when the first tree harness was in there.
This would be the tree core, right?
No. Before the tree core, it was already there.
There were two.
Tree Magic.
Yeah.
The Tree Magic was already there, and this was quite well received. We produced a still here in Isny, and it was an important harness already ever since. Even in when I look back some like 20 years ago, we had some kind of a small work safety collection beside the sports equipment that we were doing. And in this collection, the Tree Magic was one of the most important products, which for us meant some 100 pieces that we sold, but it was still produced here in Germany. We wouldn't have an option to produce more anyway. But it was
And I guess the first then known product of Edelrid was then the Tree Core.
Tree Core, and then the first really big swing, I think, was the Talon, which we worked on together almost 10 years ago. And
was in the room up there.
That's right. Yeah, and that made a really big splash, and is still today the most premium and comfortable spur on the market, I think. What have you learned thinking about the Talon project specifically? It's done, it's finished. Maybe there's a Talon 2 coming, but what have you learned from that project, or would you have done anything differently?
No, I think the thing that we learned most is the complexity that we underestimated. I think this was the biggest learning, that we started, like, you remember Carsten, and he was an incredibly motivating guy. Like when he
I feel like I should sit up straighter at the mention of Carsten. He would always slap me in the back. Sit up.
But anyway, when he was focused on that, he said, "Okay, we do that. Easy. Come on, guys. Pressure is on.
It's easy.
Race. 3 months. That's it." And then, okay, 3 months, Carsten. 3 months. The tooling probably might take, and then there is some development behind it. And in the end, it was almost 2 years.
That's right.
Probably that it took to finish it.
But it was worth it.
It absolutely was. But like, I think if we would have directly planned for 2 years and say, okay, this is a project that's terminated 2 years, I think we would have approached it a bit in a different way. But as the pressure was so high to be like, can't be that complicated, come on, pressure on. We were trying to rush through it and didn't take enough time. And in the end, we found that the decisions that we made, that were so under pressure that later on we had to repeat it anyway. And that's also a bit why we lost time in it. And this is probably the biggest learning that I had out of it.
I think the 2-part heel strap stands today as still one of the best innovations in spurs, certainly in terms of comfort, right? Eliminating the way the strap shares its girth around there, and then just simplifying getting into it, right? Leaving that heel strap distance set, and then just tightening it on the front. Like that alone to me is worth the price of admission. But then you add in the 3-dimensionally twisted shank, right? Your guys' use of like steel, right, in a very small amount to keep the weight low and the strength high, versus trying to go with a more, modern's not the right word, a fancier sounding material like aluminum or carbon fiber. I think the steel was an excellent choice. And the pads.
But the pad this was one of the nightmare details that we've been working over and over and over again. It was really like to get the shape in it and like choosing the right materials, finalizing the workmanship, because you have to stitch it 3-dimensional directly. You cannot stitch it flat and then simply bend it. And this was like one where you think the work is done. It's like the metal parts are there, the tooling is done.
Now just slap a pad in there, guys. Are you done yet?
Hey, Daniel, just put some padding in there. It can't be that complicated. Then you start. No, it has to be thicker. Then you try to bend it, and say, okay, this doesn't work when we have it thick enough. Then you can't bend it anymore. So how to get it thick enough and still possible to bend it in there, and then solving this issues with the production then, because they didn't like to stitch. They are used to stitch flat stuff. It's way easier for them, and now you have to teach them to stitch it in round, how to always shape it in the same way. And then you start to stitch, and then it starts to turn and twist, and like, because the tension is not going to fall. And it's such a small detail that no one sees in the end. It's just a padding in the end.
It's just a pad. I don't appreciate that at all. Phil, when you get an idea from Daniel, you usually have, okay, this is what I need to do, 1, 2, 3, 4 to execute. But one of the things we keep talking about is that it seems like the easy way is usually the worst way for the planet, right? It's easy to use the materials that we know. It's easy to use oil-based products and, environmentally damaging production processes. When in the process do you start thinking about making the product more environmentally friendly, and how does that kind of factor into the development process for you guys?
I don't think that there's a certain point where we think about it somewhere in the end. I think we always approach any kind of new development product from the beginning on with these kind of questions. So I would say there's like there are three things that you have to look at from the beginning, because when you don't do something in the beginning, it ends up to be too late most of the time. And sustainability is something that we of course think about, that also many people that work here are passionate about. It's one of the big reasons also to work here at Edelrid, I'd say. But it can't be like the main focus of the development, because we have obviously like products that people fall down with potentially. So there's the safety factor, and then there's the function. And function and safety is obviously already giving you a framework to work into it. And then there's the sustainability factor that comes also to this, but of course also in the beginning, because when you think about a harness, then you already have to think about, how do I cut the material? Could I organize it in a way to reduce waste? What kinds of materials are possible to use, and so on. So it's really from the beginning, but it's very much defined by function and safety, obviously, for the products that we do.
It's quite. I mean, just yesterday we had a development meeting about a rope bag that comes into the next crack bag that we want to do.
New gear alert!
It's not really a rope bag. It's just a floor sheet for a rope, and the functionality that Dina did is cool because it's a different shape. It's a small detail, but then you see it on the floor and you see, okay, if you cut the floor sheet that way, you will have small triangles, actually triangles that size, that will be wasted. You cannot fit the pattern on the raw material in a way that there is no waste. And then the discussion starts, because it has a cool functionality with this new shape, but we know that we will create waste that we can't use in any way. So we were checking, can we use those elements probably somewhere else in the backpack, not to waste it, or like change probably the shape of the backpack a bit to use that material, that you can cut all the patterns for the backpack out of one sheet without any waste, or do we reduce the functionality to reduce the waste? And this is these discussions, they're frequent, they're ongoing.
And there are some examples where the ecological factor was also maybe the initial input for development. So one of our biggest developments, I think, on the rope side was that we had the goal to make a dynamic rope that is made from polyamide or nylon out of our waste here in the production. So to actually close the material loop. And there, of course, you could say the goal was the sustainable characteristic about it. But what kept us motivating so much was the technical challenge, because it has never been done before. And yeah, people in development, as you can imagine, are techie people. So this technical challenge was actually what drove us so much to pursue this goal.
Do you feel validated that product is the best-selling rock climbing rope in America?
No, it's not.
BOA Eco?
No, that's not the BOA Eco. The BOA Eco, the difference with the BOA Eco is not made from recycled yarns, but from reused yarns.
Upcycled.
Well, I would call them reused. So our approach is we have those 3 R's, right, that everybody knows from the Jack Johnson song.
Reduce, reuse, recycle.
Exactly, yeah. And recycle is the order.
Jack Johnson.
The order actually matters as well, because it also tells you how important these steps are. Because reduce, for example, is the least famous one, maybe, but because you also don't see it in the beginning, because it's not there. But it's actually the most important one, because it prevents damage from happening in the first place. And the recycled, the 3rd R, is actually the least valuable one, because then the damage is already done. But obviously it's better than not do it. But it's the most popular one, right? Everybody talks about recycling.
Sure.
But I would really define recycling as you take something, you put it into the raw material. So there's a process to put it into the raw material. And then from the raw material, you build another product. So in terms of the rope, this means that you take scrap material, leftover yarns, you put them back into the plastic pellets and then spin the yarns out of again. So this is the recycling stuff. And then whether it is upcycled, recycled, or downcycled, there's no international definition about it, I think, but we would see as what's the value before and after. So let's take PET bottles, right? Polyester bottles, you can make polyester yarn out of it and make a rope out of it. If you made rope out of a bottle, that's upcycled because the value now is higher than it was before. If you take a rope and make a plastic bottle out of it, that will be downcycled because the value is less. If you take ropes and make ropes out of it, that's recycled because the rope, the value is equal. But of course, this is
That's the new international definition. Just in case, world, we just gave you your definitions.
But I mean, you have to admit that it's some kind of subjective. Sometimes the value is not so clearly defined, maybe. But
it's the Westenberger scale.
Maybe the Westenberger scale, yeah. But reusing is something completely different. Reusing is like I take the material and I build something else out of it. That will be making a rope mat out of old ropes, making, I don't know, like, and this is what we're doing with the Boa Eco. We take yarns from our production, and we don't change them, we don't put them back into the raw material, but we optimize the processes within our production and produce smaller batches so that we can take the yarn that has already a value and make a new rope out of it.
So instead of throwing away 200 meters of thread that wouldn't make a 1,500 meter set, exactly. You'll make a 200 meter rope out of it and sell it.
We also could recycle it, but then you have another damage, which is the energy that you need to recycle the material. And you could do new yarns out of it in bigger batches again, but this is a waste of energy in the end.
So I've got some good book recommendations.
So what you have in rope production, you have all the yarn preparation, right? Until the braiding process, and this material that we have before the braiding process are still yarns. So this is our way to reuse this material that is left over here. But then after the braiding process, the yarns are already braided, right? So to unthread them, this is not going to be the way. So for this waste material that happens after the braiding process, you got cutting, you got quality, batch control, you got packaging, and you got waste material there as well. And for this, we didn't have a use before. And now we can take this and make a new rope out of it as well. And that unfortunately isn't the best-selling rope yet in the US because it's super expensive. Because we're the only ones doing it. We build up our own supply chain for this, and hopefully it gets more commercial in the future. But
you watching, Blair? Get after it.
And it's also interesting that we're talking about polyamide nylon because that's so much harder to recycle than polyester. Recycled polyester today is commercially available. We have ropes, especially for the arbor market, the buco, the jacama. They use recycled polyester in the sheath, 100%, because that material is just much easier to recycle. Because recycling is, you lose performance of the material in every step, and with polyester it's not so bad.
I think I could talk to you guys about this like single aspect all day long. It's really important to me personally, but I think we've teased our audience enough with this harness. With this harness on here, they're going to say it was clickbait. They never talked about the harness. No, we're going to talk about the harness. This looks awesome.
This is our new Tree Raptor harness. It's so I guess everybody know the Tree Rex.
Yep.
The Tree Rex was the successor of our Tree Core harness, and with the Tree Rex, I would say we put a lot of the things we learned in rope development into this harness, into the Tree Rex. So it's a really high-end harness in terms of the technology that goes into this. And the Tree Raptor would be the model that takes a few elements of this, but scales it down a little bit. So would be a little bit, maybe the entry-level harness.
Tell us, what were some of the challenges and successes of this project?
I think this was actually one of the really easy projects in the last 18 months. It was that the definitions were clear, the requirements were clear. This is, for example, one of those projects that I mentioned before, where there was a clear requirement, market-wise, went through product management into development, and then there's clear tasks to solve, and then, like, let's say there comes, make an easy, simple, lightweight, comfortable harness, implement from tree racks the adjustability, for example, of the D-rings, and make a nice, easy design. Try to save money on the design and on the functionality.
What elements of reduce, reuse, and recycle will we find in this harness?
So on the recycled side, there's not so many options we have here. Also, what you can generally say is that, like, these principles, they get harder for safety products because the requirements are often much harder, and you have more material. So that means that using, for example, recycled material is oftentimes much more expensive. And when you have a lot of this material, it gets to a point where, unfortunately, our experience is that there's not
prices out the market,
a high enough commitment to this.
I find there is an example of reduce on the development of this. On our work safety harnesses, one of the concepts is that we want to design the products in a way that there is the 90 to 95% of the surface, they last long. They are for a long time. You don't see the wear. Therefore, it's quite good to use black because you don't see dirt on it that fast. But some percentage of the harness or also of the metal products, we design in a way that you see the wear quite fast, because you don't want to go to the work site with the brand new stuff. It always looks like you're a beginner. So it's cool if the product, if you wear it, you use it 2 days and then it looks worn, but it never looks rotten. It never looks damaged. So you look professional quite soon because the product looks worn, but then for a long time it stays exactly the same. This is why we use the bright elements every now and then in small details. And on all the work safety harnesses, we play a bit the design lines with those bright elements. And we were discussing this here as well. And usually we use materials that we stitch on, like using it as a protection element, for example, but designing it, and by that creating the design of the whole harness. And in this one, the idea was like to have a link, to create a link between the leg loop and the hip belt through the design element. And here there's an idea we had in an earlier harness already to create something like a tree. You have the trunk here, and then the head, like the top of the tree. So there's a bit of a design element. And actually we would have needed to cut these patterns out of the tarpaulin that we're usually using. And when we did those patterns, we said this is the design that we want to have. But if we want to cut this out of tarpaulin, it's clear that it's not possible to put the patterns into each other. So
lay them in.
We create a lot of waste of tarpaulin if we stitch this out of tarpaulin. And we made the first samples, they were made with tarpaulin and they look really cool. But we said we create a lot of waste now only by having this design element. We said we want to have this design element because the harness people also buy products because they look cool. That's why we changed for the printing. We said this is actually, we didn't do it for price reasons. We wanted to have the tarpaulin there because we liked it more optically. But we said we wouldn't accept the waste that we create by that. And it's a reduce element.
Not very spectacular.
It's absolutely unspectacular. You will never see it because
it's unspectacular.
Yeah.
That's a very German thing to say.
It is.
Yeah.
Spectacular.
Unspectacular.
And on that note, for sure, like what's always our take on stuff is to make it last longer or make it replaceable. And that's for example like on these elements here. So the elements that gets most wear, which is obviously the rope bridge and the the connecting bridge here to change the distance between the Ds and the
It's just simply girth hitched on here.
Exactly. So this is replaceable, and the rope is also replaceable. So you can actually also put any kind of 1891 certified rope that is bigger than 10.5 millimeter in there, and that's also sounding super unspectacular.
I actually think that is spectacular. A lot
this was actually the biggest effort in certification.
In making it so that other 1891 ropes could be used.
To discuss this with the notified body, because it's something that is always seen, at least on the German market. I know that the American market might think that this is crazy, but in the European way of looking at PPE, making a knot and just let it block there without any stitching, without anything else, is a weird thought. But again, this was already discussion for the tree Rex. That is much more complicated when it comes to the rope bridge, because you have so many other options there. So again, like for this harness, we were able to just take what we had worked on here from the tree Rex and put it in there. But yeah, this seems like such a simple thing, but it was a lot of discussion, a lot of tests to basically prove, but also, of course, for ourselves, check if there is a justified risk with this.
Interesting. Well, I'm really excited to try this harness on. One last question. The ink that you use for the printing, is it oil-based or water-based?
I have to admit I'm not too deep into this mechanism, but I'm quite sure that we are using the best option that is available, because we share the printer that we're using there with our colleagues from VD, and they did the audit and the supervision of the printer that we're using there.
Pretty sure it goes into Blue Sign products.
I'm 100% sure that it does.
If you're not familiar with VD, VD is sometimes referred to as the Patagonia of Europe, and is an incredibly environmentally responsible company that builds a variety of outdoor gear, outerwear, things like that. Definitely worth checking out. VD is the sister company of Edelrid, and there are shared resources. Guys, I'm really excited to try this harness on, which we're going to get to in just a little bit. But I think we have a ring here that we wanted to talk about, and you want to show us what you're looking at, Phil?
Because you were asking us if we can present some products that might not be on the market yet.
It's a secret. It should be blurred out, but it's not.
So this is the Cupid, the Cupid steel actually. So a connecting ring that you can open, an openable ring. But the interesting or special thing about this ring is that it doesn't have any loose parts, which is one of the weak points of these openable rings, right? You have, some of them have a screw and a barrel, so two parts to lose. Some of them have two screws,
or
one screw
that
secures the other screw. So you don't have loose parts, and also when you have a screw-based ring to open, there's always the question about how do you secure the screw, right? That it doesn't fall off in practice.
Right, another screw going sideways through it, a gasket.
All kinds of options here. And this you don't have with this because there's no screw here.
Right. Is it a T20 Torx? Is it a 4mm hex? Where's my 4mm hex? Will this Torx fit in the hex?
And I mean,
it will.
And I mean these rings are obviously also designed to be opened, but it's not a carabiner, right? It's not something that you open all the time, but you open it maybe once a day when you would prepare your gear for the day or so. And opening a screw and closing a screw again, or screwing it in again, is always the question of how do you have to put Loctite on it again? Do you have to use a new screw?
You do.
Actually,
you do have to put Loctite on it again.
If there is no other way of securing the screw.
How many people do that in practice?
Nobody. Exactly. They put Loctite on it the first time and that's it.
And with the screw as well, depending on the structure, is some rings are constructed in a way that the screw gets loaded, which makes it very elementary to the product. Well, anyways, this doesn't have all of this.
Show us how it opens. So a pointy object.
You need a pointy object, and then you have this little plunger here, and you press the plunger, and then you can open the ring, put anything in what you want, and To close it, you can use your finger actually, and it locks.
And this will be a safety certified item.
Yeah.
When will it be available, and to what certifications?
It will be available next year, so 2024, spring of 2024, and is certified as a carabiner, so after the 362 European standard. Because it opens to the inside, there's also, you could say, maybe the backup security in construction that even if, I don't know, the plunger would be damaged, gets off, when it's loaded, it wouldn't open, right?
Ever.
You have no screw to secure, you have no things to lose, you have no screw that gets loaded.
I think people look at projects like this and they think, yeah, this would be easy, I could do that. But
there were actually a lot of iterations about this product.
Very cool. You designed and iterated this in your 3D printing lab?
Of course, yeah.
Yeah. The tests are done already.
Great.
The tricky part on this one is actually, like, as it is a ring round, so load can happen in any direction. And we wanted to make sure that in really any direction, any cross-loading situation, any triangular loading situation, we're safely above the 22 kN. This is the tricky part, because usually most of the elements that you can find, they have 22 kN, but in a marked direction. But you never know in which direction it might get loaded. And some of them, they have weak spots. You know that they have 22 kN in the main direction, but if you cross-load it, or if you load it triangular, or if you load it directly on the gate, you're below the 22 kN.
These rings are actually a pretty interesting product, because it used to be okay to certify them according to 354, and that required less strength, 15 kN only. But then they changed the standard they changed the detail that these kind of products, 354 products, have to be flexible. Well, like these kind of rings are obviously not flexible. And so you couldn't certify them according to this standard anymore. And then they were kind of an outlaw product. There was not really...
What is it? Is it a carabiner? 354?
It's a pulley.
It's like...
Maybe it's a hand descender. Let me just get it certified, please.
Put a motor hitch in.
So actually there was not really a standard covering this, at least on the European side. And there was then, like, what happens then very often is the notified bodies get together and they release something that's called RFU, recommendation for use, that gives you something to work on, to certify, to put a CE on your product. And only recently now, these kinds of rings, also the not openable rings, right? Because you can't certify those to a carabiner because they can't be opened.
Right.
They only recently got their own standard now for LSDs, they are called now. That's not the drug, but load sharing devices, they're called.
I didn't think it was.
Yeah, but this actually is a carabiner, which would sit basically above this, because it gives you just more security, I guess, because a carabiner is very standard on your rack.
It's interesting to learn how complex just looking at a project like this could be. And
to sort it according to a standard and to discuss with the notified body according to which standard and requirements you want to certify it and what comes with it. As soon as
sometimes it's straightforward, yeah.
Absolutely, can be absolutely easy. But in such situations, it's not 100% clear what it should be.
Well, thank God for standards and notifying bodies. Otherwise,
absolutely, yeah.
It would be the Wild West. This is a cool product. Do we want to talk about this? The Edelrid pinch? Show us what we're looking at, guys.
Yeah, as we've been talking before, like we've been playing on brake-assisted belay devices ever since, in the last 15 years, all over again. I think in the last 15 years, especially in the sports side, the auto tubes a bit made their way.
And these types of belay devices, which are obviously primarily used for sport climbing, are also popular with tree climbers for use on lanyards. The Tringo Cinch was a very popular device until it was discontinued. What's the maximum rope diameter on this?
10.5 on the safety side.
So that's a bit of the special thing about the pinch, is that it was initially developed for the sports climbing market, not only sports climbing, indoor climbing, sports climbing, multi-pitch climbing, rappelling, so everything that comes in the sports application. But we said directly from the beginning, when it performs well in the sports, we also want to have it certified according to the rope access standard, the 12841, to make it usable also in rope access. Which definitely it will not be the device for rope access technicians. Absolutely not. 90% of the users, they will keep on buying the heavy, solid, massive stuff that you can use up to 12 millimeter ropes, and in rescue scenarios as well, probably having the certification according to the 341 as a rescue device as well. Nevertheless, there will be applications where the small, lightweight and versatile devices will make their way. I think of root setting, for example. The root setters just recently in the past years, they became more and more professional. It was like arborism 20 years ago. It was like cowboy work. Like you just grab some rope, go into the tree, cut, whatever. Sure. And they reached a certain level of professionality within the last 15 years, I would say. And the same is happening to the root setting. The root set, I mean, climbing gyms are everywhere now, and it's a standardized sport in the meantime, and it's a public sports, and therefore the root setting becomes a professional work field as well. And there I see a big potential for big devices like that, because the root setters at the moment, they are still linked very much to the sports, and they come from the sports. They are used to use the sport equipment. Nevertheless, now they have to make their way into the professionality of rope access technicians. And for them, devices like this, I think, offer big potential, because this is more or less what they're used to. They can use it on the semi-static ropes, 1891 for working. They can also use it for the dynamic ropes, the 892 ropes for belaying, for transporting the material. It's repel belay device. So this is where I see a bit of a potential for such devices. Nevertheless, the main market is the sports market.
And what we now, building the bridge a little bit also to the tree world, there such a device could obviously be valuable for positioning devices, so lanyards, and that would be also something where the one thing that is really special about this product could come into handy. Because
Nice.
this was also
I can see it coming.
This was also motivated, of course, by more from the sports application. But what's like the special thing about this product is that you don't need a carabiner. So obviously you can attach a carabiner just like on a conventional, like through the
straight through
the
here,
main holes. Yeah.
which could also even
Exactly, that's the point. Yeah. So you have
the D-ring.
your shortener just like perfectly orientated on your side,
Never
and
have the carabiner twisting, cross-loading.
never have cross-loading issues. Have it as you don't
Especially
lose
the
anything.
arborists are always the ones requesting to have everything as low as possible.
Yep.
And like a carabiner is simply another 10 centimeters, always that everything is moving up and there's more play and everything is loose. And this is something we saw a big advantage in the sports application. Nevertheless, also in the work safety, there is it's a cool.
Yeah, and this is when you tried this. It's pretty cool. It's just have it here and.
Guys, I've really enjoyed hearing your take on the environmental aspect of product development, as well as just how you look at projects. Really appreciate you sharing your time with us today and with our audience. And let's keep working on the next 10 years of Edelrid and TreeStuff's legacy together. Thank you.
Perfect. Thank you.
Okay, we're back. We're here with Daniel and Phil, and we're going to talk about innovation and safety. Tell me, guys, just a little bit. Give me your name and tell our audience what you do and how long you've worked here.
So I'm Phil. I am.
All right. That is what we have for you today. So I'm going to go ahead and let you know that there's a whole bunch more of this. We have an interview that we did with the product manager, Lucas, today. We've already done a little bit more than 2 hours here on this webinar, as well as an interview and a talk about the history of Edelrid and their focus on sustainability with Vitas, their CEO. So that's actually also going to be part of a series of videos that we're going to put out. All these videos that I'm putting that we watched here today are also going to be put out as standalone videos on our YouTube and Facebook. Not worth CEUs though. That's just this. So that you can watch those there, or you can recommend them to people. Thank you everyone for joining. If you have any last minute questions, I think we pretty much answered everything in the comments here. There were some questions about the T-Rex harness system and the Tree Raptor with the bungee chest and the knee ascender or the knee cruiser system, which we already have a video on that you can go and check out. It's a really cool system that all kind of works together there. Yeah, but if you have any questions, let me know. Okay, great. Blair, do you have anything you want to end with?
Man, I just want to thank everybody. This has been awesome. I have to say, it's I love this brand. I love the company. I love the fact that they're reinvesting, like I shared, back into sustainability. The innovation that comes out of Edelrid is super exciting. So, man, I have to say I'm more fired up than ever, and I hope everybody else is about the Edelrid brand. So I appreciate the opportunity to be on, Kel, and to share our brand story with your audience.
Yeah, and I mean, thanks for shipping me out to Germany to film all of this. Everyone was very hospitable. It was a great time. It really, boy, the shock of going from Munich airport to the international arrivals of Chicago O'Hare was just terrible. I was like, all right, turn it back around. I want to go back. But yeah, it was a great time. I think Edelrid's a great partner for us. We align in a lot of our sustainability goals, and we have a couple things coming out there in the future. So keep an eye out on things going on with TreeStuff and Edelrid. Keep an eye out next week. We should be launching that sweepstakes to win one of the Tree Raptors. And also, I forgot to mention it. Go to treestuff.com/Valentines and send in a quick video on why I love being an arborist. And because I want to make a little like Valentine's Day compilation video. So go ahead and check that out. Blair, thank you very much for everything that you do with us. And the quiz is in the comments. Have a nice night, everybody.
All right. Thanks so much.